kita akan mulai acara webinar kali ini. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera untuk kita semua. Terima kasih atas kehadirannya Bapak dan Ibu para sahabat Netromind. Sebelum webinar kali ini kita buka, ada baiknya kita berdoa sejenak. Untuk itu, mari kita berdoa menurut agama dan percaya masing-masing. Berdoa dimulai. Ya, doa selesai. Ya, selamat datang kembali nih para sahabat Netromind yang kami cintai. Sekarang temanya adalah NETCAD Hydrology Solution. Semoga produk kami Hydrology Solution ini bisa memberikan tambahan ilmu ataupun kebutuhan dari Bapak dan Ibu sekalian. Berikutnya akan kami tampilkan slideshow-nya. Ya, mungkin sejauh ini ada yang mungkin baru bergabung di webinar kali ini. Apakah sudah terlihat slideshow saya? Kalau sudah, kami akan perkenalkan dahulu Netromind itu apa sih atau siapa sih? Ya, NETCAD itu perusahaan berdiri pada tahun 1949 sebagai leader digitalisasi data spasial. Di Turki ini mereka sudah menjadi leader untuk data spasial. Berikutnya, kami dari PT NETCAD Indonesia merupakan perusahaan yang menengah yang sedang berkembang, membawahi konsultan dan trading, dan fokus untuk energi dan air. Dan kantor pusat kami berada di Office 8 Jakarta Selatan, dan kantor operasional kami ada di Cikias. Dan BES ini merupakan adalah official partner resmi dari NETCAD untuk si region. Nah, ini tampilan office kami dan office NETCAD yang ada di Turki. Head office-nya ada di Ankara. Dan berikut ini tim-tim kami yang ada di Turki maupun yang ada di Indonesia. Untuk di Turki, untuk business development-nya ada iGrim, dan untuk technical support ada Takbak yang sudah hadir di dalam webinar kali ini. Hello Takbak, can you say hello to participant?
Sure. Hi everyone. Good morning.
Morning. Karena beda 4 jam, jadi di sana masih pagi nih para sahabat. Selanjutnya di Indonesia jangan khawatir, NETCAD punya region representatifnya diwakilkan oleh Pak Yanes Darmawan, dan selanjutnya ada saya sendiri sebagai business developer Riza Matadinata, dan support kami ada Ilham Sidik dan Muhammad Siajuddin. Dan berikut ini adalah klien-klien Netromind yang ada di Turki. Sudah banyak sekali yang sudah menggunakan di sana. Dan selanjutnya ini adalah klien-klien dari kami dari PT NETCAD Indonesia. Dan selanjutnya ada university yang sudah bekerja sama dengan produk NETCAD. Ada Unsri, UHO, dan juga ITB, serta Trisakti, Unpad, UGM, dan Unsur. Dan tidak lupa juga untuk corporate yang sudah bekerja sama dengan kami ada Tekmira di Bandung. Ya. Nah, selanjutnya untuk lebih afdolnya lagi nih, kita akan dengarkan produk features dari perwakilan NETCAD yang ada di Indonesia. Untuk waktu dan tempat kami persilakan untuk Bapak Yanes Darmawan, silakan tampil.
Terima kasih Mas Aris. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi para sahabat NETCAD. Apa ini? Oke, sedikit sebelum mulai produk untuk Hydro ya, perlu saya sampaikan di sini bahwa NETCAD itu adalah perusahaan software termasuk salah satu putra kandung ya, di mana produknya itu aplikasinya banyak ya, namun yang akan dibahas di sini lebih karena untuk aplikasi mining, di aplikasi mining itu kami ada 3 macam produk yang berfungsinya adalah satu untuk modeling, pada modeling situ, yang kedua itu kaitannya dengan database, yang ketiga dengan aktivitas tambang. Nah, yang untuk modeling ini ada 2 produk. Jadi yang satu itu bicara tentang resource estimation, scheduling, optimisasi, ya, sampai dengan cadangannya sendiri gitu ya. Itu bernama NetCad. Sedangkan yang kedua itu bernama NETCAD. Jadi NETCAD itu lebih ke arah software engineering sebenarnya. Hanya ada modul-modul di dalam sana yang bisa digunakan di aplikasi tambang seperti kayak survei, plotting, gitu, pemetaan geological map, gitu ya, digitalisasi dan lain sebagainya. Dan yang kedua itu untuk perhitungan cut and fill volume. Dan modul di situ juga yang kita akan bahas saat ini nih, yaitu NetHydro untuk aplikasi hidrologi. Jadi menampilkan untuk DAS dalam area sungainya, basin atau catchment area, basin, catchment area, sampai dengan analisa curah hujannya, yang mana ujung-ujungnya kita ingin memappingkan area-area mana saja yang bisa berpotensi memberikan banjir, seperti ya, yang mana itu penting untuk pengguna melihat mapping di daerahnya dia seperti apa sih. Nah, jadi yang akan dibahas di sini lebih ke arah ke software NETCAD, bukan software NetCommand, di mana di situ ada NetHydro. Oke, untuk yang database-nya itu murni pure database data geological, yang mana kita taruh di cloud, ya, sistemnya cloud, dan itu bisa ditaruh di servernya klien atau server kami, yang mana kira-kira continuous both ways. Yang ketiga untuk aktivitas tambang, itu lebih ke arah monitoring pergerakan dari portnya sendiri maupun foodnya gitu ya. Ini nanti akan kita bahas kapan-kapan hari seperti itu. Oke, lanjut. Slide berikutnya. Oke, ini sedikit dari mengenai NetCommand, ya, bicara tentang geological modeling, open design, open optimization, dan underground. Mungkin sahabat-sahabat di sini sudah familiar karena sudah banyak software juga di Indonesia. Kurang lebih fungsinya sama NetCommand ini. Jadi full modul semuanya itu dari awal protokol input ya sampai pembuatan geological modelingnya, blok model, perhitungan resource estimation-nya di sana dengan geostatistik, dan juga dengan metode perhitungan yang lain. Lalu juga ada untuk open design, ya, untuk mendesain tambang dan juga untuk underground-nya juga ada. Dan yang kemudian ada proses optimisasi dari si objek kita. Next lagi, kita dilakukan sama, kita cepat aja sih. Lalu ini yang tadi saya sampaikan, NETCAD. Jadi modulnya itu ada laser, ya, SCADA, laser untuk surveying, SCADA untuk perhitungan cut and fill volume. Lalu Kadalis itu lebih ke arah ke water management-nya, sama dengan network water, kurang lebih dia akan combine. Sedangkan HYDROLOGY lebih ke arah untuk ujung-ujungnya mengevaluasi daerah banjir. Next. Oke, software NetCommand seperti juga software NetCAD ya, itu didesain sangat user friendly, sangat simple, di mana user bisa menggunakannya dengan banyak kesulitan gitu ya, karena juga dia Microsoft based, fitur-fiturnya maupun juga command-commandnya gitu ya, cara tinggal klik-klik aja, dan juga beberapa input yang diketik pakai keyboard. Dan juga mempunyai sistem licensing yang mobile, ya. Jadi beda dengan yang software yang lain, di mana yang mobile itu biasanya itu adalah gadgetnya, laptopnya gitu ya, atau komputernya, atau mungkin ditaruhnya di server, tetap dia license-nya nempel di situ, atau berupa dari dongle, ya, dongle nempel di situ license-nya, ya, semacam flash disk yang bisa dicolok develop dan bisa dipindah panen. Nah, untuk si NETCAD GIS maupun NetProman software yang mobile itu license ya. Jadi kita ada semacam soft key atau kita namakan license code ya, berupa kode-kode yang encrypted. Ya. Nah, itu yang akan dipasukkan ke dalam software kami untuk bisa mengaktifasi license-nya. Nah, license code ini bisa kita mobile dengan cara copy paste saja dan ditaruh di misalkan media komunikasi yang lain, baik SMS, WhatsApp, email, dan lain-lain, tanpa harus memindahkan asetnya. Komputernya tetap tepat, yang pakai si user A, dia tinggal diaktifasi license-nya, lalu license-nya dia kirim ke rekannya di si B yang berada di manapun di dunia, lalu si A akan tekskan license code ke B, si B copy lagi dan pastekan lagi ke software NETCAD, GIS atau software NetProman di laptopnya dia, dan dia tinggal klik tombol aktivasi, ada internet, langsung order. Jadi nggak repot untuk penggunaan license-nya. Dan tentu saja tersedia dalam bentuk license yang perpetual. Ini hanya apabila ada yang ingin membeli license-nya ya. Jadi kami masih menyediakan yang license yang perpetual. License perpetual seperti namanya atau artinya itu adalah abadi. Jadi license itu akan aktif forever. Dalam catatan forever di sini tentu saja selama NETCAD masih berdiri. Kalau NETCAD sudah bubar, ya berarti license-nya udah susah karena server udah kemana-mana. Jadi itu akan perpetual dan juga tersedia yang untuk para rekan-rekan yang di konsultan ya, atau mungkin yang dengan ya, miners yang menggunakan atau menggunakannya dalam cakupan waktu pendek, itu tersedia juga untuk sewa bulanan atau sewa tahunan. Tentu saja harganya akan lebih ekonomis. Oke, next. Oke, ini adalah pengenalan terhadap paket yang ada di software kami, baik itu NetProman maupun NETCAD GIS. Jadi NETCAD GIS ini paketnya disediakan ada 5 macam, yaitu surveying, road, excavation, hydrology, maupun water suit. Isinya itu apa? Itu ada di sebelah kanannya, di mana kolom sebelah kanannya itu berisikan modul apa saja yang ada di paket tersebut. Contoh, surveying itu adalah modulnya isinya NETCAD GIS, NetSel, dan 3D. Sedangkan misalkan untuk hydrology, nomor 4, isinya adalah NETCAD GIS, NetSel, 3D, dan NetHydro. Jadi itu modul-modul yang ada di paket tersebut. Sama seperti NETCAD GIS di atas, yang di bawah di NetProman juga tersedia dalam bentuk paket, 5 paket juga. Jadi kami senang sepertinya dengan angka 5, jadi 5 sama 5, ya, biar adil. Nah, jadi 5 paket yang ada di NetProman ini, ada geological modeling, ada open pit, optimization, underground, dan NetProman full. Jadi pengertian license full modul di NetProman itu isinya adalah modul geological modeling sendiri, ada open pit mining, ada open pit optimization, dan sebelah tombol kolom sebelah kanannya itu berisi training duration-nya. Jadi karena diperkirakan materi trainingnya itu dihabiskan dalam berapa hari. Terus setiap hari. Ya, saya kira cuma cukup itu aja pengenalan sedikit refreshing dari apa-apa yang pernah disampaikan sebelumnya untuk para partisipan itu pada ikut webinar kami. Atau mungkin sesuatu informasi baru untuk yang baru join. Ya, ini kan. Satu note juga informasi apabila nanti ada yang ingin tahu lebih, itu saya ada taruh di kolom chat di webinar ini untuk nomor handphone maupun juga untuk silakan mau bisa kita demo. Ya, begitu saya Mas.
Baik, penjelasan sangat komplit sekali ya Pak Yanes, mantap sekali. Selanjutnya saya pengen tahu nih para sahabat masih semangat nggak nih untuk menyimak webinar kali ini sebelum technical support kita akan membawakan acaranya. Masih semangatkah para sahabat NetProman untuk mendengarkan materinya? Saya harap masih semangat ya. Oke, langsung saja kami tampilkan technical support kami yang ada di Turki. Untuk itu kami persilakan Takbert, time is yours.
Alright, thank you. So I will share my screen. I guess you can see my screen at the moment.
Yes, we can see.
Okay. So first, I would like to introduce a little bit of the interface. This is our NETCAD GIS solution. And in here, we can manage CAD and GIS based data together. So today, we're also going to do the same. We'll be working on databases and also the CAD layers. In here, we have a couple of tabs, which some of the tabs belongs to the NETCAD GIS. And if you would like to use some specialized solutions, you can always pick one of our packages. For example, the XCANet, it's an excavation package. Water solution for designing water distribution channels. NetPro professional road design tool, surface tool, and it goes on. So today we're also going to talk about the NetHydro solution. To begin with, we need, of course, some data to work on. What we are going to add is, we are going to add a terrain model, and then we will do the rest. But for starting, actually, we need to create a new basin analysis template. So, just a second.
Mas Aris, jangan lupa min. Jangan lupa foto bersama ya.
Okay, sorry. So let me show that again. So to begin with, we are creating a new Hydro basin analysis template project. While we are clicking on it, it's actually connecting a database. It's a simple one, MDB. It's connecting to the MDB layer. And in here, under the references, we are going to be dealing with the database systems, and in the CAD layer manager, we are going to deal with the CAD data. So first one, I'm adding one sample project. This is an NCZ, this is our extension. So if you're using a NetCAD, this is also one of our extensions that we use. So in the extension, as you can see, there are some CAD layers, but that extension also capable of carrying the database, raster images, satellite images, also the CAD based information all together. So what I import is actually the terrain model. Let me change the layer names for you. So triangle model, and I do have point, which we can also say poi. So for poi to be seen, I will just increase this size. Yeah, in here we do have a point, and behind that we do have a triangle model. In that kind of solutions, in GIS-based solutions, what we do actually before starting a project, also making sure that we are in the right projection definition. So in Indonesia, you do have some EPSG codes as well, according to the region that you've been working on. So you can directly paste some EPSG, or you can make the definition from here as well, the UTM selection, the datum definition, You can make it here. So EPSG will be created here automatically also. When you click OK, the projection definition will be done. What's the good use of that is actually now we can bring satellite images as well in accordance with the data. So I'm working in that region. I can see that. So this is the satellite image. Maybe I can also bring street map. Okay, so this is the region that I'm working on in Turkey. We will talk about it soon, about that region as well. So, yeah. Once we are done with that definitions, actually, we can start on hydro projects. So there are two ways of starting a project. The first one is actually finding all the basins inside the triangle. And the second one, finding a basin according to a point. So why we are using those two definitions differently, separately? If you find all of the basins, all of the rainfall areas, it will be easier for you to decide in which region you are going to work, or you will see all of the catchment areas. So while you are making building something new, a new structure, you can avoid those catchment areas, and the catchment, actually waterways, you can avoid it. So you can build your, I don't know, any kind of structure out of the catchment areas. So you will be safe in terms of floods. Yeah, because of high raining hours, you might get some flood disaster. With that, actually, you can avoid while you're making a design. So the point actually is useful. Let's say we do have a structure here and one catchment goes in between, and you would like to make a structure so that you are going to calculate a specific flood flow. So that's why you're selecting a point, then you are calculating what's the flow exactly in that point. So those are a couple of different applications. Let's start with the general one. That might take a little bit in terms of time. Okay, first it's creating the raster image, and then according to the raster, we have a lot of cells, and by using checking all of the cells, the software actually finding the catchments. So yeah, like I said, it might take a while. The software finding those basins according to the terrain model. So if you don't have a terrain model, it's not going to work. It's filling the empty areas with water. So as long as you get rain, those areas will be filled first, and then the other ones. If you're wondering about the method, what is working behind the scene, it's a TSAN method. According to that, actually, it's filling the empty areas. And also it's showing us the directions which water actually goes. So in the meantime, maybe I can also mention about the databases. Later on, we are going to fulfill those databases with information, but databases have tables, and inside the table, it's holding different attributes. In NETCAD, you're also capable of converting the spatial data like this one into a CAD file, which I will also show you in further process steps. Okay, it's the last one. Okay. So the software found all the basins and the sub-basins now. So as you can see, there are lots of small sub-basins, which you can also manage those information from here. You can uncheck the basin sub. You can uncheck the basins so that you can only see the main ones. And catchments, sub-catchments, we can cancel so we can see the main lines. So those are our main basins and main catchments inside them. And those are the branches that when raining, it's actually first getting collected in here and then it flows into the main catchment. So the branches and the main one. So what we would like to achieve, actually, we would like to get an idea what's the potential of precipitation drop in terms of millimeter. That's why we are going to make some rainfall analysis. Also, we are going to calculate some flood flows inside the basins. So yeah, let's bring back our satellite image. Let's move that category under everything so that we can see clearly. Okay. So according to the terrain model, actually you can also see some roads inside the catchment areas. So lower places, it's actually fitting with the information that we have. Okay. To continue our project, to make that analysis, rainfall analysis, for example, you are going to need a weather station. We are creating some weather station points, which also can be done manually. When we do that, we are capable of adding some information inside of it. For example, let's click on it. I already have some weather stations in the database, which is in Turkey. All of the weather stations are recorded and we have their data, the rainfall data. So once we click the weather station points, we can actually bring the weather stations, but we are not capable of seeing them now. I will just create a label. Region, is a name. Okay, so the closest one to my area, there are some stations, which is Çamlıdere Station, Kızılcahamam Station, and Güvem Station. So those are closest weather stations to my area. And that weather stations have some information. By the way, projection definition is quite important because otherwise you're not going to work in the quite accurate coordinates and your weather stations might be far from you. So be sure at this stage of the project you make projection definition. And yeah, so when we have the weather station information, now we can make some analysis, rainfall analysis. We can move forward to that. But first, we are creating the rainfall areas. Also, I would like to show you that street map So as you can see, my weather station matches. It has the same name with the place. So Kızılcahamam weather station. Also this one, Çamlıdere, the same place. So I'm working in the quite accurate coordinates at the moment. All right, now we are going to create some rainfall areas. Why we do that? Because in our topography, different weather stations will affect that area differently. We are getting some information from the weather stations, but a weighted average of these weather stations to the basins are different. That's why we are going to separate. We are going to create impact areas for the weather stations. I click the rainfall areas. From quick selection tools, I will make a weather station selection here. And I will use area. I will select one area. So let's say we are going to work in that area. So I drew this area. And the software will automatically split that according to the weather stations. So as we can see, the station in the right-hand side affects more area. You can also think like the information we are getting from that station, like 35%, this one, let's say 30%, and this one is 25. So multiply 25 with Çamlıdere station, multiply 45 with that station, and add on, then divide it into 100. So it affects that area more than the others. That's why while we are using the numbers, while we are using the weather station numbers, there will be some differences in terms of area. So when we create the rainfall areas, now we can make some rainfall analysis. There is one more step before I move into. I also would like to mention that. So our terrain also have a soil class. What I mean by that depends on the soil. Actually, we are running some tests with the Schmidt hammer. And according to that, we are defining the class, which class is the soil is, like A, B, C, D for different classes. And then we are selecting our area. Either it's an agricultural area or it's a forest. Depends, totally depends on the terrain that we are working on. But eventually, we are defining some number in that soil class. We are defining in the digitized section. I bring the flood flow calculation tools here. In here, you can also see the weather station. You can add weather stations around your terrain. You can fill the information of your weather stations as well. The thing that I'm going to work on is a soil classification. So I will click on that and I will define some area. So yeah, in this area, I will use soil class 82. That means 82 of the water flows, but 18% goes under. At the same time, it also means that. So 82 soil class I defined for this area. Okay, it created a CAD layer as well. So I unchecked the CAD layer. So we will just see the boundary now from now on. I can't see the hydro section. Okay. Now, we can make our rainfall analysis. You can basically draw the same area like you drew before to separate weather station areas. We can make a calculation in here. So what we have here, we do have 3 weather stations that affect our terrain, and you can see the measurements have been done by years. I mean, according to the years, these are the events, one event that has highest precipitation. So according to the years, we are getting highest number of precipitation values, and we are recording that into the database we already have. But for Indonesia, you can also add some new values here. You can select which ones you would like to use. Sometimes if you don't want to use, you can uncheck some of the others as well. I just checked every information in here according to the years. I will also do the same for the other stations. So this one has a record of 1994, and this one until 2014. This one is 1999. So you might ask, if it's not equal, does it matter? It's actually doesn't matter that much. It calculates according to the stations what is potential rainfall information in the following years, but it's actually using the maximum information always, because by using that we are designing structures. So imagine like that, 72, the high number in here, 52 we have. So according to its periods, the software decides in 2 years that precipitation could be the maximum. It finds the distribution, actually, what kind of distribution is closer to. That's why while we're calculating the rainfall according to the old stations, it's using different distribution methods. Gaussian, log normal with 2 parameters and 3 parameters, Pearson type tree distribution, Gumbel distribution. It's using all of the distributions and it checks which one is more accepted. So according to the software, the Pearson type is more accepted. So you can consider those numbers in terms of years. So in 2 years, expected rainfall is 36.4 millimeter. In 5 years, there will be definitely 45 millimeter rainfall or something close. And in 10 year expected to happen is 51. So yeah, it goes and on. And according to that information, later on, we are going to calculate the flow, and flow will help us to understand what would be the sizes of the structures that we have to decide. Let's say we're going to create a set or channel, then we can decide which channel can contain, let's say, 100 meter cubic water per second. Okay, so according to the year, as long as you are there, for example, for a mine project, I'm there for 10 years, so I can make a design for 10 years as well. If I'm there for 25 years, I will use 25 years information to make a design. Okay, when we click OK, it actually gave us the report on Excel. So it's the it's the same thing what we've seen on the software. Those results for Çamlı Dere Station, those results are for Güvem Station, and the last one is for Kızılcahamam Station. Okay. So once we're done with rainfall analysis, we actually measured the millimeter precipitation. So while we are making a flood flow calculation, we have a couple of methods. Let's check them. Okay. For example, the rational method. Rational method has different coefficients. So it's a CIA, but we are using 3.6 coefficient extra also to use metric system. So we are using this formula for the rational method. Actually, this is how it calculates, but we are using meter cubic, that type of units. That's why the coefficient might be different. So for the flow coefficient, for the C here, we are using coefficient. For the I, it's intensity, rainfall. A is area already. And 3.6 is just the fixing number. In other formulas, it's also 0.278 or something. It depends on the units that you're using. So we are using that unit because we are making measurements with the meter units as well. For the flow coefficient, we are selecting our area type. Like I mentioned in the soil class, I made my soil class definition, but it has different soil class. Usually that soil class is like 0.5, 0.6, or 0.7. It comes differently in here. That's why we are going to select a different coefficient. But I will select something intense, like, yeah, maybe this one. Okay, 0.85. And as a rainfall intensity, I will use, actually I got the reports, but it's fine. I will use something like 30, because in the other stations were 20s and only one station was 36. So I will use 30 for the rainfall intensity. Now, which basin area we would like to measure? That's the case actually. I can either select the main basin, so I can select the whole basin in here, or I can make a selection for the smaller ones. For example, this one, or this small one, which is a main basin 6. So it's highlighted. It's a red now. So I can make that calculation for this one. Usually, the rational method works quite better for the smaller areas as a method. So I will select that small area. And now, for how many years I would like to make that analysis. This is the maximizing factor that we are using in Turkey. I don't know if you have it or not, but for being in the safe side, we are multiplying the results with 1.13. So we are increasing the results 13%. Just to stay safe. So if I find a flood flow calculation at the end, instead of 100, I will find 113. So this is just the increasing the results, increasing the output we are using in Turkey to be stay in the safe side. And also the pluviograph coefficient. So according to the distance you have with your terrain and the weather stations, there are some pluviograph correction coefficients as well. So we are correcting the number according to the distance. Actually, it works. So if you are so far away from the weather station, you might choose another number. If you're close, because it also affects where you make the measurement and where is your actual terrain. So we are using a coefficient to fix it. And yeah, this is the yield calculated. Or maybe leave it. So according to that, we are getting some results. Rainfall intensity that we define the follow coefficient in QP value comes from the rational methods. It also runs with some other methods as well. You can see the results in there. I will also try to do one more thing in the rational methods. I will select 0 point, let's say 75. And for the rainfall intensity for 2 periods, I would like to select that weather station and then the basin. Basically, this basin is affected by only this weather station. So I can make a selection of that weather station. So yeah, it find a different number, as you can see, instead of a general number. Yeah. Now, the Q values that I can see is like 55 for 2 years to be expected. In 5 years, 92. In 500 years, this is the maximum. So that events and the periods works together. So that event can happen in a 5 years. It also says the rainfall intensity for the years, like 2 years, 5 years, 10 years, 25. So those are the expected information. This is the QP value, comes from the rational method. It actually finds the critical hour is 1 hour. The general harmonic slope is like 4.2%. This is the general harmonic slope of a catchment in the selected basin. And yeah, the participation of that weather station is actually 100% because we select a small one, which is inside that station. Okay. So I will use the other methods as well. Of course, the numbers will be a little bit different. In the Marcus method, it directly calculates the coefficient of a basin. In Turkey, we are usually using this coefficient, so that's why it's a default. But you can also type a different coefficient for your calculation as well. It includes also the harmonic slope because in a rational method, we didn't mention about any harmonic slope, but slope also might affect the flow, right? So according to the slope, your gathered water flows even faster if it's going somewhere down. So this is another approach, the MOCUS method. And it also includes the harmonic slope as well. So the base and main 6, again, I'm selecting for 2 years, like I did before. The critical hour, I will select 1. Now it will give me the results according to the MOCUS method. So the thing about the methods, actually, rational works better for under 1 kilometer square. The MOCUS, I should have using in between 1 to 10 kilometer. It's more efficient. And there's also Snyder method, which we will use. It's more effective on the areas that has higher than 10 kilometers square. So keep that in mind. There is also some sort of a relation. I find that those results might be slightly lower than expected, but it depends on the methods as well, in which areas that we are using is these methods. Okay, let's run the last flow calculation with the Snyder method. In the Snyder method, there is some CT and CP coefficients, storage and the catchment capacity. So there are some numbers, but 3 types of numbers you can find it on the internet, but 3 types of soil. One of them is kind of like swampy, one of them with sand with gravel, and the other one was clay, if I'm not mistaken. So it has coefficients. The sandy one has 1.65 to 0.56, if I'm not mistaken. Yeah. So you're just defining one of the 3 types of soil. And according to that, Snyder calculates. Snyder actually have some charts. So while you are making a manual calculation, you need to find your place on the chart. But software, of course, you don't have to do that. Software already does. In the basin area, I'm selecting this one. Yeah, basin main 6. It's probably too small for the Snyder method, but let's do it. 1 hour critical hour. Okay. And these results come from Snyder method. like 12 for 5 years expected flow. 500 years, sorry. 12. What was the MOCUS? MOCUS was quite big. Okay. Because my area is not that big, actually, I can check. I can check the area information.
Jawab Mas Aris, Buriana. Buriana jawab.
Can I? In here, because of the zoom, actually, it's hard for me to see the upper side. That's why I'm trying to move. Yeah. In the net surf, I will use create elevation from shape future, and I will turn main basins into a CAD layer. So this one is actually have that basin information. If I check this one, the area is okay, 12 million meters square. So it's going to be 12 kilometer, which Snyder is actually fine in that area. It's not that small as it seems. Okay. So according to the Snyder method, I will move forward my design. I'll bring back the references. All right. Now we need to move forward with the load analysis. So this is the next step. For 2 years, I made my calculation. What's the result of the Snyder? It's kind of like 12. So I will use 12 load for calculation. With the sections that I'm going to use, let's see if every 40 meter works or not. Okay, I will make 20 meters, so we will have dense sections. And during Manning coefficient is okay. All right, those are the intervals for the sections that I'm going to use. I only use how many years I will make a calculation. It's a 2 years, and I use the result of a Snyder method. Okay, this is what I've been doing. And when I click OK, it asks me to choose the basin area. So I will select the basin area that I used. main basin 6, right? When I click OK, it does the calculation. Also, that calculation is connected to the software HYDROLOGY. Maybe you also know that it sends the information there and it makes the calculation. Yeah, this one. Okay, it actually finds the flood area. So in that basin, this is the main catchment that we have, and the gathering, the flood area is this, and I can see it. Okay, what we can do, the actual area is inside the database. It's a flood results. And the cross sections, the green ones are here, and the blue ones, the water levels, are here. So we can see that the results in our software and HYDROLOGY both together. It's possible. For that, first, I'm also going to turn that flood result into a CAD file. So instead of basin main, I will also get catchments as a CAD. So the flood results, or let's make catch main. So main catchments, I will make a CAD layer. Main catchments. So this one now, the main catchments, are CAD layer, catch main. I will make them blue. Okay. What else? I can bring the sub ones. Catch sub. Okay, the test that appears is actually my CAD layer that I'm transferring. So catch sub, right? Maybe for the main, I can make it choose a darker color. Yeah, okay. And the last thing that I would like to bring here is the flood resulting area. Okay. So when I uncheck the references, now I'm capable of seeing that I still have the catchment and the sub ones because I moved them into a CAD layer. And this one is actually the flood area. So I will move that information into this. I will use change layer future. I will select that information. It will move that from test layer to my selected layer. Okay, I don't need that test layer anymore. So I do have a CAD project too right now. Let's save that project once. I couldn't see where did it save, so Hydro. Webinar, Indonesia. Okay, so I saved all the database, all the raster images, all the CAD layers. Now, what I would like to do is actually, I would like to create a raster image, another raster image, which is going to be original terrain surface. So I will uncheck some of the CAD layers, spatial layers. Unvisible all, and soil class, weather station. Okay, I will bring back the satellite image. Now I would like to save that part as a raster too, because my triangle works with that region. So I will save that part as a raster image. And then I will drape that image into the surface. So there's a GeoTIFF save option. I will save this part. Satellite image, satellite webinar, I will use. It will add that to the references when we save it. I am not going to change any projection definition. Yeah. In the meantime, I can also show you the HackRust results. Once you do the calculation of your project, it will automatically send that into the HackRust software, which is free, by the way. You can also download it. You will see the output of your results, like some sections. Here. And the general view, like this one. This is the general flood area representation. Okay. So I think we need to wait for a little while for the raster image. With that method, actually, you can turn any satellite image to your raster image. Basically, you can get that images from the satellite image, as long as you have the projection definition. If you type the EPSG code correctly, you will fit your data with the right coordinates, and then you will be able to use the satellite image so that you can save some raster from there too. In the meantime, if you have some connections, I can try to reply until this part. Actually, there's nothing much left out. We are close to the end. I will actually show you the final results. We made the rainfall analysis, and we made the flood calculations. We did the flood analysis, and we saw that what the flood area looks like. We have the Q value, which we can use for future structure designs, right? And basically, we're getting closer to the end. I will just show the final form of all the catchments, all the flood areas, and the terrain surface all together. So that's why if you have questions, I can reply now.
Yeah, textbook have a question.
Yeah, I saw.
Yeah.
What kind of database? Is it a weather station database? Because if it's a weather station, we can add that weather station manually, and we can type the rainfall analysis according to the years, and we can use it. For example, I worked on that area, right? So basically, I can just digitize one point if your weather station is near to your region, I mean the terrain model. You can click one point, you can digitize one weather station, and you can fill the information and do the calculations. It is quite same information. I have the database of all the weather stations in Turkey, but actually I don't need it. I just used 3 of them. And one of them, because my basin was inside Kızılcahamam station, in the right one. So basically using one station was enough actually. But yeah, you can manage the weather station database. You can add new weather stations, and you can add the information according to the years. It's not a problem. Otherwise, all of the databases is just creating information automatically. We create the basins when we started to the webinar, like it took like 6 minutes, I don't know. So it find all of the basins and import that into database system. So it create a database system, and then I'm capable of turning that database system into a CAD file as well. So this is what it does. I hope that answers your question. If not, please correct me or ask me in another way.
Can I speak straight away, Pak Arizal?
Ya, silakan Pak.
Okay.
Silakan, Pak
Chandra. This is Chandra from PTCNI. What I'd like to know about the soil classification that you have the database in the screen. Yeah, I just wondering because we have many soil classification in Indonesia, which is different in every area. So that's the one that I'd like to. Do we have also to upload it and then put into this database that we can use for this analysis, or from the NETCAD already actually put into the database that we can use it straight away? Thank you.
Okay, I got it. I'm going to minimize it then. Yeah. Let's find it. Soil class, or no, runoff curve. The one that we are using looks like this one. Yeah. The soil type, if you remember, I defined something like 82, and the one that we are using, hydrologic soil group, is that one, but we are using that soil type for Snyder and Mokus methods. Okay, we are defining that soil classes for Snyder and Mokus method. For rational method, it has its own database. When the process is complete, I will show you again. But it's 05, 07, 08, that kind of coefficients it has.
Is that answering your question, Pak Chandra? So I don't really understand what kind of database that we are talking about here. Is it the weather station database, or is it the soil database?
For the weather station, when I can actually understand, we can actually digitize it. Yeah, so we can add our local weather station itself. Yeah. Which is right. And also the data we can also update manually from our data, because we have also the data, and also we get it from our data up in the local weather station that we usually every year. Yeah.
That's
but
correct.
The soil classification, that's one that I like to know, because it's also actually in our area. Soil classification, yeah, maybe the same with this the database that Tukbek already showed to us actually.
Okay. So basically,
could be different. Like I said, I defined an area and I use 82. So I was using this one actually, similar to this one we are using in Turkey. But for Snyder and Mokus method, it works. So I'm manually selecting which one I can use. There's a forest, but according to the Schmidt hammer, there are different results. I mean, different soil types in the forest as well. That's why I'm selecting one of them and using it for the forest, for example.
Yes.
But it's only for Mokus and Snyder methods. For rational method, it has its own coefficients. I will just show it once the process is complete. It took longer than I expected because I underestimate the area, I guess, even though that small part was above 10 kilometers square. So I think it's a little bit big area. Yeah. Okay, in hydro, blood flow calculation. Okay, there's a flow coefficient. The coefficients are here for the rational method. For urban bases, for road platform surfaces. But it's even doesn't matter, because if you're going to use the rational method, and if you knew your coefficient for the region, you can manually type it here, like 0.3 coefficient. It's totally fine. Okay, I will add the raster. Okay, raster that I have now. I have the triangle. All right, now it's a final shape. So I will send some layers, for example, triangle, and I will drape the satellite image on it. And I would like to send the catchments, also the sections. Okay, let's see.
Hasilnya akan 3 dimensi dari sini.
So, in general, this is how the catchment sub and catchment main are distributed. Let me give some transparency to the surface. Okay, so those are the main catchments. And when we add the sub catchments into that, it flows into the main catchments. It's quite looking accurate, right? According to the topography surface. So it's logical that water will going to be collected here. And also the area, the flood area of my selected basin. Here.
Look, can I ask you something about the result itself?
Yeah, sure.
The one that the let me show you if I can make this the area that we very dense, or maybe so much volume of water actually it is actually retained in there, or it just only like the one that we have. I cannot show in here ya. Pak Arizal, saya nggak bisa pakai ininya ya, untuk saya masih nunjukkan gambar di sininya ya, karena saya lihat di sini nggak ada.
Oh, bisa Pak Chandra,
ya.
share screen ya maksudnya?
Nggak, saya mau bikin ini tunjuk. Ini artinya apa ya? Mau saya tunjukkan di dalam gambar ini di sini. Jadi katanya di lock ya.
Oh, coba.
Annotate. Bentar, coba saya pakai ini ya, saya gambar. Saya pakai annotate-nya dulu. Kalau memang bisa saya akan kasih. To work, What does
Yeah.
it mean in this? You can see the red circle that I made.
Mm-hmm.
Yeah, that's what does it mean actually?
It's a flood area.
It's a flat area.
Yeah.
Okay.
So this is the currents, the flow that
Okay.
going through the catchment. Okay, this is the current that I show you. The Q500 current goes through that catchment.
Yes.
Of course, it's moving forwards from highest location to the lowest location. Seems like that direction. And if flood happens, that area shows that these areas will be affected.
Will be flooding, yeah.
Yeah, flooding.
Okay. Okay, Tugbek. Thanks for the confirmation.
Sure. So we made a map of basins and the catchments. Basically, while we're making designs, first we can avoid making any kind of structure near to those areas. And the second, if we have ongoing structures, we can also calculate the flows, and we can make protection structures according to that flow, which is another phase.
So again, Tugbek, so this software actually only give us this kind of information before actually we going into like a detailing for the structures designing, yeah.
Mm-hmm.
Yeah.
Because in the structure design, there are lots of different things that we can do. Basically, we can make a channel. Let's say we would like to direct that flow into somewhere else. Let's say we can make a channel here and we can direct it to another path. We can make a wall. Simply, I will say wall, water structure, and we can prevent that water to reach some certain level. If we have ongoing road, for example, let me draw it. Ongoing road in here, let's say, right?
Yeah.
If we have a road, it's a simply culvert.
Yes.
Will solve this issue. So the water structures are a little bit different. That's why. But everything starts with the flow. So we know the flow and we can make those designs as well.
Okay.
So there are lots of different types of water structures, and engineer or maybe the team should decide which one will be most beneficial for the project. Like I said, if it's a road project, simply a culvert can solve that issue. Maybe in some cases, we might use a channel to direct that flow into some other paths, some walls to protect the region from a flow like with a certain level. So different type of water structures can be here.
So does it mean that the NetHydro itself, there is like a library for kind of structures that we can use for designing, or
there's actually one
channel and culvert only, yeah.
Mm-hmm.
Okay.
According to the basin area, we can calculate the sloped wall. Okay, let's say, what was my results? 500 and 12 to 13, okay. 500, 1000. 12 to 13. Manning coefficient, let's say agricultural land. Harmonic slope was 0.042, it was. Right side of this. Left side of this designs. Water level and the base area. Not accepting. I think it's there's something in here. It actually shows the other way around, so don't get confused. 2 to 4, let's say 2 to 4. Okay, we are sending that information to the HECRAS also, and HECRAS does some calculation. Okay, in some parts, water height should be higher than specified by the user. Okay, in some cases, water level is higher. So I will increase that to 3 meters. So actually you can make a control and decide the water level, the base area, and the slopes, of course, right and left slopes we selected. And the less part, I think, water height. Let's directly make something like 10 meter to 5 meter. I think it will accept. By the way, there's also thing, we are making this calculation for all the catchment. Actually, we don't have to do that. That's why in some parts, the water level could be quite high. 8 to 8. We need to use find basin according to the point future, actually. Because instead of calculating a channel for fulfilling all of the catchment's requirements, yeah, most likely we are getting rid of. That's 10 meter to 12. Yeah, let me explain. So while we are making the calculation, we do have a catchment, and we are making a calculation that fulfills every side of the catchment right now, because we are making a design for all the catchment. But actually, this is what we need to do. For example, we are going to put a channel here to direct that water, let's say, somewhere else, right? So what we have to do is actually calculate the basin according to that point. So this is going to be my basin, and I will know what's the exact flow in the selected point. So with that way, actually, it's going to be much more accurate to design the water structure or defining the sizes. But yeah, let's run. Eventually, it will fulfill all the requirements of the catchment anyways. Yeah, only here, how much? It's 11-ish. I think 12 meter will be okay. So that's 14, 12 to 14. Oh, okay, 15 meter difference, highest. Seems like. And this coefficient is a little bit high, so I will select the soft clay. No, there are even some parts that 30 meter water level difference. Yeah, but let me explain it with the image, the 3D image that we have. So it didn't work because my triangle layer wasn't open. Okay. Just a second. Okay, this design also for the same data sets, I mean the triangle is the same. in here. So you remember the stations. This is done according to the points, but what I'm saying is in some parts, the elevation is different, and let's send that to the 3D. Close all. Triangle model. Yeah, triangle model and the sections will be okay. Yeah. In some parts, water level may reach, as you can see here, water level may reach up. And in some cases, for example, here, we are not even seeing the water level much. So what I would like to say, while we are designing a structure, it calculates actually according to whole catchment. So instead, if we calculate just the point and the Q there, so it will be much more easier. And there's also one another applications which I didn't do that one, so I will just share it. It's another water protection thing that can be done. So this one is culvert. We are making size calculations in our road package in here, basically, for the culvert. We do have a NetPro, and inside the NetPro, we are actually making a culvert calculations if there's a road. This is one. And yeah, sizing. This one is the channel one, and this one, I forgot what it's called. But it's for the sections, actually side of the paths. For the drainage. Yeah, I think you got my point. For the drainage, the side of the paths, let's imagine like a road, and near to the road there are some sloped parts, and for that there's actually sizing too. So this is another application. Okay, do we have a question?
Bagaimana Pak Chandra? Apakah kira-kira sudah jelas ya?
Sudah jelas. That's enough for me. To work. Thank you. Terima kasih.
You're welcome.
Mungkin untuk yang lain, Pak Hari, mungkin ada pertanyaan atau Pak Asari gitu ya. Silakan Pak.
Boleh, Yanes.
Ya, silakan.
Thank you, Tukbak, for the presentation. I think this software is quite easy to understand. I have two inquiries. The first is if it is possible to determine how many weather stations are required in a specific location. For instance, maybe how many weather stations are required for an area of 100,000 square meters. My next question is that usually not only waters enter the pit, in certain area mud is also formed which enters the pit due to water erosion. Is there a feature available at NETCAD Hydro to predict the mud that will accumulate in the sump? Because this will help us in making a good planning. I think because the other reason is the cost required to remove the mud from the pit is 10 times greater than the cost of pumping water. Maybe that's my questions. Thank you.
Okay, I understand. So at the practice, actually, we define an area, and according to that, we create impact areas of the weather stations. So you can actually find out how many weather stations are needed if you know their location. So let's say this is your area or basin that you are going to work on. And you have one station here, the closest one, and the other one, let's say here, and the other one is here. So it's using the Tyson method, and it's finding those geographics according to Voronoi method, basically. It creates a line and it divides in between. It creates a line and divides in between. And according to that, it creates the impact areas, okay? So impact area of this weather station maybe look like it's going to be like this one, and the second one will be quite the same, right? And the third one, actually we didn't made. Yeah, so the third one will deal with above. So according to that, your area will be inside that weather station zones anyway. So you don't need the other weather station information, but it stays in between. Then you might need other weather station data as well. If those areas are intersects, if your area is somewhere in between here, let's say, then let's make it like that. Then partially it's in this region and partially is in this region and also in this region. You can check the Voronoi method applications. It's like I said, but I couldn't draw it well. We do also have that feature in NetPromine 2 for the boreholes. It's just defining the impact areas of the points. This is the main thing of a method. So according to that, like I said, sometimes, which also I had the same, if you remember, I select a small basin and it was inside Kızılcahamam station right here. But if I would, if I should select bigger area, then all stations would be needed. So it's actually related to that. calculation. And for your second question, yes, mud flows also, but there's, as far as I know, there's not something calculates mud flows for those areas. But if you do the protection, actually, all the rainfall areas and all the catchments in here, you can actually catch which waterways, sub-waterways, your area is located to. It's probably because of the precipitation again. And I'm guessing if you can make a drainage in, let's say you are working in that region, and most likely all the mud comes from that part also. If you can make a protection from here, if you can cut the line so no mud will be getting into your line, so you might need some sort of a protection structure a little bit outside of the field. Maybe it will also help with the mud, as I'm guessing, but of course, just saying, I didn't see the area, I don't know the exact cause, but I'm just thinking it's also because of the rain, precipitation, and flows.
Oh, okay, I've got it. Thank you, Tukber.
Okay.
Ya, ada lagi yang mau bertanya? Sinyalnya kurang baik.
Yeah, we have that here actually.
Yeah, Takbak, maybe your connection, right?
Can you hear me?
Yeah, we can hear you.
Okay. Okay, I was just doing the drawing. So this is how it works. The Voronoi method splits the total distance in between stations and creates impact areas for each station. So again, you can check the method. So if we don't have any other questions, I will thank you so much for your participation.
Okay.
Participation, yeah.
Yeah. Thank you, Takbak, for your explanation, for your present. Dan selanjutnya mungkin para audiens kita coba foto sesi dulu ya, on cam sejenak.
Photo session?
Ya. Mungkin Pak Dijim bisa ngambil.
Mas Arizal sedang foto.
Oke. Untuk Unsri Alivia sama Unsri Rafli ya, mungkin bisa on cam sejenak sama Pak Hari kalau bisa. on cam dulu Pak Hari biar terkenal.
Pak Ari masih di pantai ya.
Oke.
Ayo Bang.
1, 2, 3. Ya, sekali lagi ya. 1, 2, 3. Oke, terima kasih para sahabat pemain.
Makasih banyak.
Ya, setelah selesai juga foto sesi dan webinar kali ini kami tutup dengan mengucap alhamdulillahirobbilalamin. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Sama jangan lupa next webinar di tanggal 24 Mei ya, insya Allah. Dan berhubung tanggal 23 sudah Ramadan 1444 Hijriah, kami atas nama MILZ Indonesia dan
Waalaikumsalam.
bye sahabat pemain.
Terima kasih Pak Chandra, Pak Hari, terima kasih.
Terima kasih Pak Chandra,
banyak ya.
Pak Hari, Pak Hari.
Thanks a lot.
Terima kasih. Thank you Pak Chandra.
You're welcome.
Yes. Bye-bye.
Bye everyone. Have a good day.
Bye-bye.
Thank you Pak Bert.